We have a car moving at constant speed over a curved bridge. And that curved bridge is here like this. Position shown, the car has a radius of curvature of 50 meters. So R equals 50 meters. Why is the car accelerating even though it's traveling at constant speed? So again, to the format, what we want to start with is a definition or a principle. And once we define it, we say right off the bat, acceleration is the rate of change in velocity, delta V over delta T. Velocity is a vector that has magnitude, the number, and direction. A change in either means a change in velocity. The car traveling on a curved path is continuously changing direction. Change in direction is change in velocity, and change in velocity means a non-zero acceleration. So notice the construct. We start with a definition. Acceleration is a rate of change. We start out with another given. Velocity is a vector has magnitude and direction. So here now we're talking about a change in either means a change in velocity. The car is traveling around a path, continuously changing direction. Now we get into the conclusion part. Change in direction is change in velocity, and change in velocity means constant non-zero. So a lot of work, but it guarantees we're starting with a premise or a definition and ending up with a sound conclusion. Question B, we're asked to draw and label the vertical forces acting on the car in the position shown. And this is where we want to be careful. So we start out, and we've always had our ubiquitous gravity, the force of gravity. So remember, we treat everything as a point object. And so we go from the center of the object, and that is the force of gravity. The force normal acts at the point of contact, which is here. And it happens in both places. So both of those are the force normal. And we should draw them in such a way that each of the normal forces is about 1/2 the weight. So that's the forces, and we want to be careful to draw it that way. The next, we want to calculate the maximum speed, and all of this is about forces and centripetal accelerations and such. So let's start with our dear friend Newton's second law, which is F net is the sum of the forces. F net is ma. And the force in this case we're dealing with is the force of gravity. The acceleration is centripetal, so we have mv squared over r, and the weight is mg. Then we see m on both sides. We ask, is it of the same object? This is the mass of the car, and this is the car that is accelerating. So indeed, m's cancel. And this is why we should not panic when we think we need something like the mass and we don't have it. Turns out the answer to this question is independent of the mass, is all it means. Then doing some quick algebra here, we get v squared is rg. V is the square root of rg. The square root of 50 times 10 is the square root of 500, and that is about 22.36 meters per second. Our numbers, the most we could hope to get to is 2, so we would just leave it at 22 meters per second. And that would be the velocity, that the centripetal force would be equal to the weight. That's the fastest it could go. And that's question A33.